Looks like we're recording. So, today is the most important lecture for the rest of the semester. Okay? Over the next 4 chapters, we're going to be doing a lot of hypothesis tests. We've done a few confidence intervals to now, and confidence intervals and hypothesis tests are kind of 2 different ways to do the same thing, essentially. And so I do want to emphasize that a lot of the rules that I'm going to give you today apply to confidence intervals. A lot of the underlying assumptions apply to confidence intervals as well as hypothesis tests. So this can also help you with confidence intervals, but I'm going to focus primarily on hypothesis tests because that's what we're going to be teaching you. So I call this my chapter 10 to 14 outline. Okay, so I'm going to give you guys how many steps here. Every once in a while I update this. 8 steps. Okay, I'm going to write 8 steps here, and in one sense, you'll find that a lot of my lectures from here on are going to be very repetitive, and we're just going to apply them to different tests. But you should plan on using these 8 steps on almost all of your homework from here on out. Okay, and this will help you hopefully to get the right answer. Okay, so step number 1: list all important numbers from problem. Things to include, so proportions or means, and you should hopefully be able to distinguish between those two. B, standard deviation. Be sure you can distinguish between population and the sample. That will be a very, very important skill. C, note the N and the alpha. Okay? Based on that information, you should ask yourself, is the data categorical or quantitative? Okay. Well, actually, let me throw one more on there. Categorical, quantitative, or regression. Okay. Step number 3, find the null and the alternative hypothesis. Okay. Based on your quiz scores, it seems like most of you did pretty well on that, so that's good. Sometimes that can be a difficult step. All right, now, step number 4, okay. This is the step that's hard, okay? And it is pick the correct statistical test. Okay? This is where students are going to mess up. Okay? Now, just so you know, I'm going to teach you like 13 different hypothesis tests. That's why this step is so hard. Okay? So, if your data is quantitative, okay, these are the choices that you could pick. First of all, it could be a 1 sample mean where you know population standard deviation. and that's going to be a z-test. Okay? It could be a one sample mean, and you don't know population standard deviation. Okay? That's going to be a t-test. It could be, still on the board here, a two sample mean. Okay, that's also going to be a different t-test. It could be a two, actually, oh, I forgot to say that that one's independent. Okay, it could also be a two sample mean and dependent. That's also a t, but it's going to be a different equation. Number 5, it could be an ANOVA, which is going to be an F test. We haven't learned the F test, but that's coming down the pike. Okay? It could be 6 two population standard deviations, which is also an F test. And it also could be 1 population standard deviation, which is the chi-square test. Okay? So that's if the data are quantitative. There's a list of 7 tests for you. Okay? So that's why step 2, it's important to properly identify that. So you get a Z, a T, an F, or a chi-square. You got 4 choices of tests. Okay? Now let's go to if it's categorical. Okay? If it's categorical, you have a 1 sample proportion, which is going to be a z-test. Okay? You've got a 2 sample proportion, which is also a z-test. You have an independence test, which is a chi-square test. You have a goodness of fit, which is also a chi-square test. Oh, that's it. Okay, so 7 and 4 is 11. Oh, you know I left one off of here, didn't I? We've got regression, which is basically a slope test. That's going to be a t-distribution. Let me throw another one on here. This is some of my notes here. Going back to if categorical, it could be a 1 sample one sample proportion, but it's a small sample, and so that makes it a binomial. Okay? So that's 7 and 5 is 12 and 1 is 13. Yeah, that sounds about right. Okay? So over the next, whatever we have left in class, we're going to learn these 13 tests. Okay? And I have had students memorize this. It is kind of funny because sometimes we get in here, and I remember one time I asked what kind of a test it would be, and the person said the correct test, and I said, why is that? And he said, because I memorized your outline. It's like, wow, that's impressive. So the one thing that I will just add here really quick is if you want to memorize it, I guess you can, but in the course of the class, what I'm going to try to do is I'm going to try to help you think logically about which test it should be. Okay? All right, so that was step number 4, which, as you can tell, with 13 choices can be the most difficult. Okay? Let's move on to step number 5. Step number 5 is to find p-value. Okay? Step number 6, compare to your alpha. Step number 7, you need to decide whether you're going to reject or do not reject the null. Okay? So this can also be a difficult step. And what I'm going to do is I'm going to give you a saying. Apparently they teach this in the in the math lab. It's not a politically correct saying, but it is memorable. Okay? So the question is, how do you know whether to reject or whether to not reject the null? Okay? We always, whenever we're doing a hypothesis, we're always comparing it against the null. Okay? And the phrase is, if the p-value is low, okay, reject the hull or the null. Okay? Easy to remember. Okay? And when we're saying low, that's why we're comparing it to our alpha. Okay? If your p-value is lower than our alpha, oh, and let me just throw this in here because sometimes I forget. If I don't give alpha, assume alpha equals 0.05. That's the most common one. Okay? And sometimes I do forget. So if I forget to tell you, just assume it's 5%. Okay? All right, and then finally, step number 8. Okay? Write the conclusion in English, not statistician. Okay? And what I mean by that is do not use the following words: reject, hypothesis, and especially the word accept. I may have to take off more points than it's worth if you do that. Okay? So All right. Let's do an example. I'm going to pick a different color here. And I'm going to try to pull an example out of the book. And we're going to go through these 8 steps. By the way, these 8 steps are not in the book. Okay? So, let's go through this. Let's do an example here. Okay? This is a good one because it's got a lot of distractors in here. Okay, researchers in Illinois find 219 of 500 earn a 22 on the ACT math test. Does this represent that less than half of students are prepared for college math? Okay, so we're basically saying that a 22 means you're ready. Okay? And use alpha equal to 0.05. Okay? So let's go through our 8 steps. Step number 1 says to list all of the important numbers such as proportions and means. Are there proportions or means in this problem? What do you think, Jordan? You'd say proportions. Okay, so what are the proportions we're looking at in here?
500.
Okay, so you said 500 is what?
Sample size. Like n equals 500.
Okay, so your n is 500. Okay, so here we go. Your n equals 500. Okay, right off the bat. Okay. And then you said 219 of 500. What does that represent? Is it a mean or a proportion?
It's a proportion.
Okay. Which proportion is it? Can I get that all on there? Oh, it doesn't quite fit. Actually, it's pretty close though. You're writing something down, but I'm not hearing.
I'm just going to say it's a proportion.
Which proportion though? It is a proportion.
What do you mean about proportion?
We've got a sample proportion, we've got a population proportion. Okay? It's a sample proportion, so what do I use for sample proportion then? What letter?
It's just S.
S is the wrong answer.
Just P.
Is it P? It's also the wrong answer. Juan?
P hat.
P hat. P hat is the correct answer. Why is it P hat?
Because P is for population.
P is for the population, and P hat is for the sample. So your P hat is 219 over 500. Okay? Now, the idea here is, remember, we've got to distinguish between population and sample. And I know we thought that was easy back in chapter 1, but it's coming back with a vengeance from here on. We've got to be able to distinguish between samples and populations because it's going to affect our choice in step 4 as to what this is. Okay? So P, okay, so we went here. Researchers in Illinois found 219 of 500, so that's P hat, and it's 500. Earn a 22, is 22 a useful number? Only in the sense that we're defining them as college ready. 22 is really not really a useful number. On the ACT math test. Does this represent that less than half of students are prepared? So did we get everything in here? Do we know the standard deviation? Not really. Okay. So yeah, and my alpha is 0.05, so I'll add that here. Alpha equals 0.05. They didn't mention anything about standard deviation yet. Okay, which means what? We either don't know it or we got to figure it out. Okay. All right, so is the data quantitative, categorical, or regression? What do you think, Boyd? You got a 33% chance of getting it right.
Would be categorical.
Categorical because? So they're ready or they're not ready, or is that what you're telling me? Who agrees with them? Who agrees that it's categorical, you're ready or you're not ready? 1, 2. Who disagrees? Who doesn't know? There should be a lot of hands in there. Okay, yes, you were right. Good job. You're ready or you're not ready. Those are the categories. Very good. Now this step can be a very difficult step. It must be because the majority of you didn't raise your hand. Okay? All right, so find the null and the alternative hypothesis. Okay? So let's pick on Josh. What do you think that the null and the alternative hypothesis are? Can you remind me from yesterday what the null hypothesis means? What are the things we need to look for? You have that in your notes from yesterday? It doesn't change, so it's okay. So there's no difference. And what else? I think I gave you like a list of 5, didn't I? No change, no difference. Fair coin. This isn't really a fair coin.
True.
Soon to be true unless you find evidence otherwise. Almost always has an equal sign. Let's just put an equals in there for now. Okay. What else? There's one more thing. Who's got the one more thing?
Always about population parameter.
Always about the population parameter. Okay. That's an important one. Okay. So what's the population parameter I should be using on categorical data? We'll go back to Josh again.
What was that?
What's the population parameter I should be using on categorical data? That's why step 2 is important.
Not sure.
Okay. Let's see, who else can I pick on? Juan, it must be your turn.
Would be P.
P? Who agrees with P? 1, 2, 3. Is that a hand? 2.5? 3.5? Who disagrees? Okay, P is correct. So, Josh, P equals what? Equals 219? Who agrees that it's 219? Nobody? Who disagrees? 1, 2, 3, 4, 5. What do you think, Josh?
Half.
You think P equals a half? Who agrees with a half? 1? Who disagrees with a half? 1, what do you think?
22.
22? No, Josh was right. P equals 1/2. I don't care whether you put 1/2 or 0.5. Why did you say 1/2, Josh?
Because it says, does this represent less than half? of
Less than half. Oh, you know what I think I forgot to put on there? For yesterday's notes, if you want to go back and add this for the null, okay? It is often not stated directly. That's another one, okay? And in fact, the alternative is often stated in the problem. And in fact, this is a perfect example of what I'm talking about. Does this represent that less than half of students are prepared for college math? Less than half is what? That's your alternative hypothesis. Less than, so Josh, what should the alternative be? P less than 1/2. Okay? Because that actually is stated in the problem. Okay? Less than half. And so the other Josh was correct in noting, oh, that's your null hypothesis right there. That's your null. This is, and because it's not directly stated the P equals 1/2. The alternative is stated in there. So you got to pull that out of the alternative hypothesis, okay? So there's no difference from 1/2 is the null. Does that make sense? That's why this gets a little bit tricky, okay? All right, so we decided that it's categorical data, so we get to throw out this, right? It's definitely not any of those 7 tests, okay? So we've cut it in half. If it's categorical, now we've cut it down to 5. It's not regression. Okay? So is this a 1 sample proportion, a 2 sample proportion, an independent chi-square test, goodness of fit, or 1 sample proportion small?
Did you teach us how to identify if something is a regression? Because I have no idea.
We have talked about regression.
Okay. So like,
And regression is basically a slope test. Are we testing the
we're
slope?
talking about like a rate? Like, is that what the problem was? How
Do you remember regression? Regression's y equals mx plus b.
Yeah. So
Okay,
like in the
and that's your
problem,
slope.
would it like say something about like a rate? Oh.
No, we'll cover this. We won't cover this one for a while, okay? But basically, we're testing the slope m, okay? To give you a quick, short answer, okay? We're going to cover that in a future one, okay? So, and in fact, yeah, it will be towards the end of class that we cover regression. But we have talked about regression back in chapter 4, if you remember. All right, so we've got a list of 5 here, okay? By raise of hands, who thinks this is a 1 sample proportion? 1, 2, 3, 4, 5, 6. Who thinks it's a 2 sample proportion? Nobody. Who thinks it's an independence chi-square test? How about a goodness of fit test? How about a 1 sample small proportion test? Didn't raise your hand. You just want to get it wrong?
Yes, to be independent.
You think it's independent? No, the majority was correct. It is the 1 sample proportion Z test. Okay? Now, do you guys remember what is the equation for the 1 sample Z test? Who remembers? Chase remembers.
That'd be the, let's see, P hat minus P.
Very good. P hat minus P over.
It's the square root of NPQ. Square root
So
of
close.
P times Q over N.
P times Q over N. Very good. Okay? I know those are easy to mix up, but yes, that was good on the second try. Okay? So that's the equation we're going to be using. Okay? Each one of these are going to be associated with a different equation. So while I just put z, not every one of these z-tests are the same. Okay? So this is the z-test for the one sample proportion. So in this case, z equals p hat, which is what, Eric? 219 over 500 minus p, which is what? One half divided by the square root of
1/2.
1/2
1/2
times 1/2
over 500.
over 500. Okay, we'll punch that in our calculator, and theoretically we will get negative 2.77. Okay, so we use this. Next step here is step number 5, find the p-value. How do I do that? Josh, it must be your turn again.
Is that where we look at the chart?
You can look at the chart, or what's the other option? What if it's on the computer? We don't need no stinking chart, right? Okay. Now, the question is, in fact, I should put an extra thing here. When you're finding the p-value, WWRD. What does that mean, Boyd? What would Rick do when finding the p-value? He would draw a picture. What are we drawing a picture of? You're not sure. Juan knows.
Normal distribution.
Normal distribution, very good. Okay? Got a normal distribution. The mean of the normal distribution is? 0. And what did I get? I got negative 2.77, which is on the left side. Do I want to shade the area on the left or on the right? And how do you know? What do you think, Juan?
The left.
The left, because
We're trying to find out if it's less than.
the alternative hypothesis says your p is less than 1/2. Okay. Very good. All right. So I want the area on the left. Is that what the chart tells me? It is. Okay. So if I look at my chart, so we need to know there's both the chart and the computer method. We'll do this chart first. Okay. Excel. Okay. We'll do it both ways here. Okay, if we're doing this on the computer, z equals 219 divided by 500 minus 0.5 equals the square root of 0.5 times 0.5 divided by 500. We'll underline that so it looks like a fraction. Numerator divided by denominator is 2.77. Chart. We're looking at the chart. Here, actually, let's do the computer first. Well, the computer works the same way as the chart, right? How do I do this on the computer? What's the command? Josh remembers. Binom dist. What is it, Eric? Norm as dist, okay? Norm as dist, because we're using the z distribution of that. And we get 0.002. This area here is 0.002. If we look it up on the chart, whoa, here we go. Go to the chart here. Negative 2.77. We're going to get 0.0028. Okay? So that works. In fact, let's just plan on going 4 decimals. Whenever you find your p-value, just give me 4 decimals, okay? So in this case, I got a p-value of 0.0028. Now we're going to compare that to alpha. Okay? 0.0028 compared to alpha. And the alpha is 0.05 here. Okay? So do we reject or do we not reject? And the question you should ask yourself, if the p-value is low, is my p-value lower than my alpha? It is, okay? 0.002 is less than 0.05, so therefore I reject the null. We reject the null. We think that there's evidence here. We no longer believe that the null is true. The null said that p was 0.5. The alternative is p is less than 0.5, okay? So we reject the null. Now we have to write our conclusion in English, which means do not use the words reject hypothesis, and especially not the A word. Can't even believe I wrote that on the board, okay? So answer this question. Does this represent that less than half of students are prepared for college math? Yes, there is evidence that less than half of students are prepared for college math. Now, I will tell you this. What's really frustrating to me is when somebody goes through and they get all the steps right, and then they blow it on 7. Or on step number 8, I mean. 7 or 8. Okay? Probably the hardest steps are 4, 7, and 8. Okay? Although it's hard. Okay? So we're going to focus mainly, 10.2 is focusing mainly on the one sample proportion z-test. Okay? We're going to use these 8 steps from now on to introduce every new test that we're going to learn. But this is the one we're learning in this section. So this is the equation you're going to need to know for tomorrow. Okay? All right. I wish I could have done a small sample one, because you could get, if it's a small sample, it's going to be a binomial. And so what does a small sample mean? How do we decide if something's a small sample? NPQ is less than 10, right? Okay? And so 500 was clearly going to be fine. Okay? All right. See you all tomorrow.